Hi everyone, I hope you're okay, and I really hope that the videos will keep uploading and helping you out. On this video, guys, on this video I'll be doing the seventh question, uh, whereby I'm tackling past exam question papers relating to Doppler effect. Please do expect a total number of 11 questions, and all of these questions, guys, are extracted from past exam question papers. It is very important for you guys to know how to tackle exam-like questions. I believe it will give you an edge whenever you write your exam. So please do share the video to your peers as well, so that they will have that edge too. Okay, don't forget to subscribe, ne? A police car is moving at a constant velocity on a freeway. The siren of the car emits sound waves with the frequency of 330 Hz. A stationary sound detector measures the frequency of the sound waves of the approaching siren as 365 Hz. Take the speed of the sound in air as 340. So what happens over here, guys, is that we have our source, which is a police car, and our source is moving towards a stationary sound detector. So the sound detector is our listener or our observer. Are you together? And since our observer is detecting a greater frequency compared to that of the source, it simply means that our source is moving towards the stationary listener. Are you together, guys? Before we even answer the questions, let's write down the information we got from this passage over there. Our information, I know that the frequency detected is simply 365 Hertz, and then the frequency of the source is 330 Hertz. The velocity of the listener is stationary, it's 0 meters per second. We don't know the velocity of the source, or rather the speed of the source. And the speed of sound in air is simply 340 meters per second. Okay, now let's answer the questions. Firstly, they want us to state Doppler effect in words. It simply states that it's an apparent change in the observed frequency of the source as a result of relative motion between the source and the observer. I'll say that again. Doppler effect is the apparent change in the frequency of is the apparent change in the observed frequency of the source as a result of the relative motion between the source and the observer. Okay. Then 6.1.2, they want us to calculate the speed of the car. I have my original equation there in the formula sheet. It simply says FL is equals to V, which is the speed of sound, plus or minus the speed of the listener, and then V plus or minus the speed of the source, all multiplied by the frequency of the source. Né? Okay, remember that, guys, our listener is stationary, which simply means there at the top the velocity of the listener will simply be 0 meters per second, and hence I'll be only left with the speed of sound only. At the bottom I will have the speed of sound as well as the speed of the source multiplied by the frequency. But now all I need to know, guys, is which sign am I going to use over there. Né? Since the source is moving towards the listener, I will use a negative sign there at the bottom. Are you together? Since the source is moving towards the listener, I'll simply use negative sign there at the bottom, and then all I have to do is to just substitute. The frequency of the listener is simply 365, and then that's 340 meters per second. I still have 340 minus OVS, and then the frequency of the source, it was 330 Hertz. All I have to do now, guys, is to just isolate OVS. How can I do that? Firstly, I just need to cross multiply. Né? I'll simply have 365 multiplied by 340 minus OVS. This is equals to 340 multiplied by 330. Okay, so this simply means whenever I divide both sides by 365, I will be left with 340 on the left hand side minus Vs is equals to 340 multiplied by 330 all over 365. And then I'll simply have negative Vs on the left hand side is equals to 340 multiplied by 330 all over 365 minus 340. And therefore, let me check what does this give me. I have 340 times 330 divided by 365 minus 340. Negative Vs will simply give me negative 32.6027. So that's basically the negative 32.6. I'll obviously divide both sides by -1, and hence the velocity of my moving source is 32.6 meters per second. The speed of my source is 32.6 meters per second. Okay, the spectrum of a distant star when viewed from an observer on Earth appears to have undergone a redshift. Use your knowledge of the Doppler effect to explain the term redshift. Okay, when redshift occurs, guys, it simply means that whatever source you are looking at, it simply means that whatever source you are looking at is moving away. Are we together? And whenever it is moving away, we will observe the frequency towards the red spectral lines. Are you together? So whenever something it is redshifted, it simply means that it has a lower frequency but a greater wavelength. Are you together? When something is moving away, we as observers, we will see that it will have a lower frequency but a huge wavelength. Yeah, that's how, guys, we're supposed to tackle this question over here. Just stay tuned and wait for more videos. Bye.